All right. Welcome everyone to a new webinar from Spectral Evolution. Thank you for spending the time today with us. It's a fairly short webinar. It should not go over 30 minutes, but it's a very interesting one. Today we're going to talk about a topic that's of interest to a lot of people studying vegetation, which is the study of small vegetation samples such as pine needles and small leaves. So I think it will be a very interesting topic for a lot of people. So my name is Nicolas Vangeau. I'm the director of Spectral Evolution. And today we're going to have one of our remote sensing specialists, Mackenzie Woodman, do the webinar. Before that, I'm going to spend just a couple of minutes presenting Spectral Evolution for those of you who may not know about us. So Spectral Evolution is a company based in the USA that has been in business for 20 years now. Actually, this year is the 20th anniversary. And we are a leading manufacturer of UV-Vis and NIR spectrometers and spectroradiometers. So when we talk about UV-Vis and NIR, that means that the range of most of our instruments goes from 350 nanometers to 2,500 nanometers. One of the characteristics of our instrument is that after 20 years of development, we've developed the highest resolution instruments and the highest sensitivity instruments. So the spectral data that you obtain with our instruments is of the highest quality of any other instruments available on the market. And that's why we actually are able to do studies on like small samples like pine needles. So some of the applications that our instruments are used for are a lot of hyperspectral application in remote sensing. So whether it's ground validation data, geology information on your field of view, calibration of data for satellite or hyperspectral cameras. The instruments are used a lot as well for mineral identification, so in the mining industry. And then because of their high resolution, they are used as well in the lab for radiometric calibration transfer, for instance, or measurement of light sources. So a very wide range of application for those instruments, whether they're in the field or in the lab. But today we're going to mostly focus on vegetation measurements, so field measurements. Mackenzie is going to discuss two of our instruments, the well-known RS3500 instrument that has been one of our typical instruments for many years with 8 nanometer resolution, but is going to actually compare this data with the newer instrument, which is the Natural Spec. So the Natural Spec is a high resolution instrument and high sensitivity. So you'll be able to see data from both those instruments as they apply to characterization of small vegetation samples. So I'm going to leave the floor to Mackenzie. And at the end of the webinar, we will be happy to answer questions that you may have. So you may use the chat box on your screen to send us your questions. And at the end, we will gather them and respond to them. So thank you so much for joining us. I'm pleased to announce that Mackenzie is going to do a great webinar for us. Thank you.
Thank you very much, Nicholas, for the introduction. Like he said, we are going to be discussing advancements in NIR spectroscopy on pine needles. And so I will start with an introduction to our leaf clip adapter. So our leaf clip probe is specifically designed for leaf reflectance measurements, including small leaves and pine needles. So our pine needle adapter or small leaf adapter connects directly onto the end of our leaf clip probe. It features an innovative design that provides a streamlined and effective approach to scanning vegetation while ensuring that the sample is not harmed. Our unique design puts the integrated light source further away from the sample to minimize heat damage for repeated measurements. The design also features a swivel head that provides a built-in white reference, and it makes for easy transition between measurements. As you can see, we're using it in the field here to measure vegetation health and collect spectral measurements from leaves. So these can be used for red edge and water content, as well as many more applications. So on the right here, there's a picture of the pine needle adapter being used actively. There's a few more pictures of it later in the presentation. There's also functionality with some different vegetation indices like NDVI and NDWI for water content and chlorophyll content. So now the first thing I'm going to do is introduce leaf reflectance measurements and leaf spectroscopy as a whole. Leaf reflectance plays a critical role in studies on evapotranspiration, hydrology, plant health, climate change, and many more studies. Leaf reflectance is used because it is often symptomatic of the environment as a whole, so it can indicate drought or nutrient deficiencies, which is why it's also used heavily for precision agriculture as well as for validating and classifying remote sensing images. With the pine needle adapter, this opens up a wide range of more species of plants that can be studied in this way with more targeted approaches. So the most common method of pine needle spectroscopy is to create mats of the pine needles. This is due to the AOI, or area of influence or interest, being smaller than the pine needle being smaller than the area of interest. So this is a way of stacking the needles on top of each other or next to each other in order to get a good reflectance curve. That being said, the measurement of several pine needles is going to be the average of several pine needles. And so if you target an individual needle, you're getting a more targeted measurement. So there's also been studies into the different limitations of these pine needle mats. For instance, they've been shown to enhance mutual shading of adjacent needles, multiple scattering, and reabsorption. The primary limitation to measuring a single needle is that the signal will be lower. However, our instruments have been shown to be sensitive enough to overcome that reduction in signal. And as you can see here on the top left, we have our pine needle adapter. The needle slots into that that line where the red arrow is pointing, and is actually held in stationary for repeated measurement and very precise measurement of a single needle. So for this study, we conducted a short study to exemplify the performance of our new pine needle adapter. And so for this, we collected 4 different species of pine needles. We measured them with our high resolution instrument as well as our standard resolution instrument and compared bundle measurements to single needle measurements. These were averaged and standardized for comparison, and then we explored a few targeted studies that can be conducted using our pine needle adapter that couldn't otherwise. So these are some pictures of the different pine needles that we chose to use. The goal of choosing these pine needles and species was to get a representative sample of different geometries of the needles and leaf shape, as well as different sizes. And yeah, so now we can get into the data. So this is the needle spectra versus the bundled spectra. And as you can see on the left, we have a bundle versus the needle for needle 3, and the spectra is almost identical to the bundled spectra. This shows that we're not losing quality of measurements by reducing the area or the target. So we were able to target a single needle and get the same quality data from it. And on the right, we can see that the spectra is different. This is the small leaf. And because it's different at the 1400 nanometer mark and the 1900 nanometer mark. And these are primarily due to water absorption. So what we're seeing here is a difference between an individual needle and the average of the bundle. So we're getting more information from the individual leaf than we did from bundling the leaves together. We were also able to target the stem of the leaf and compare it to the bundle. So oftentimes when taking field measurements of needles, there will be influence of the stem within a bundled measurement. And so we're actually able to see that influence in the bundles in this spectra. So in the red circle on the left, you can see the green is the stem and the blue is the bundle, and the red is the individual needle with no influence from the stem. And you can see that the stem is flattening out our chlorophyll absorption, and a little bit to the right in the second circle, it's flattening out that red edge response as well. And then there is absorption features in the circle to the right that is present in the bundle but not present in the individual needle. So we're getting a more accurate representation for field measurements using our adapter than otherwise. So here we're able to compare the resolution and sensitivity impact from using the two different instruments. So the brown curve is the 3500 instrument, and the blue is the NaturSpec, the higher resolution instrument. And so as you can see, with the reduction of signal, our less sensitive instrument suffers with a little bit more noise. That being said, there's still both representative spectra. However, with the decreased signal, the NaturSpec outperforms the 3500. Noise can be a big factor when identifying different absorption features, so it's critical to have the best sensitivity in your measurements. So now we'll explore some of the targeted studies that can be explored by researchers in the future. Here we show a fresh pine needle compared to one that has been aged over several days. And you can see that there's significant difference in the water absorption features at 1400 and 1900 nanometers. We're also able to target the top of a leaf versus the bottom of a leaf, and which was previously impossible using bundled spectra. You're not gonna it's very difficult to align pine needles to be up or down, or small leaves even to be up or down. And so here you can see we were able to differentiate the top of a small leaf versus the bottom of a small leaf, and they have very different spectral curves here represented. So in summary, we can collect more targeted spectra despite the reduction in signal. The spectral data is of the same quality using the NaturSpec, and it is easy to identify differences between the groups. In some of the individual needle spectra, there was loss of there was some, in individuals using the lower resolution instruments, there was the loss of signal, but it's able to be overcome using the higher sensitivity instrument. And in some of the spectra for the bundled, you could see the influence of the stem. So by removing that, we're able to overcome that that influence, bringing more accurate measurements to the field. And we're also able to overcome the repeatability issues of having bundled pine needles that are very difficult to keep in the same place and take repeated measurements. So in summary, the key conclusions are that the needle adapter allows for more targeted studies, allowing us to target that individual needle instead of the average of many. We demonstrate the reflectance measurements are comparable. The quality of measurements are comparable to the bundled pine needles. We demonstrate that the sensitivity is incredibly important with the reduction of signal. However, it is overcome using our higher resolution, higher sensitivity instruments. And the pine needle adapter is able to take out the influence of the stem in bundled measurements. What we've presented here shows added functionality to the field of remote sensing and opens the door to future studies on smaller targets, like small leaves, dry or fresh small samples, and many more studies. So thank you very much, and I'm happy to answer any questions on the study that we've conducted and any questions on our instruments as a whole, or spectral evolution. Thank you very much.
Thank you, Mac. Thank you so much for this presentation. I think it's very interesting to a lot of the attendees here. So now we're going to take some questions. So you can use the either the Q&A tab or the chat box to send us your questions. So so we have actually a couple of questions. So one of the question is, so somebody has a already an instrument with the our standard regular leaf clip, and they're asking if the pine needle adapter is a brand new leaf clip or it's an attachment. So actually the needle adapter is a plate that adapts to our existing leaf clip. So it's a small accessory that is in addition to the current leaf clip. So if you already are using a spectral evolution instrument with a leaf clip, you don't need to buy a new leaf clip. You just need to buy the adapter to be able to do the analysis on the small samples. Another question is, can this adapter be used with any instrument? So as Mac showed, you can use this with any spectral evolution instrument. However, the sensitivity of the instrument makes the difference on the quality of your data. So the pine needle adapter is just a way to hold the needle in place and make sure that you capture the correct field of view, but it is not going to increase the sensitivity of your measurements. So the instruments will do that. So if you have a natural spec instrument with a high resolution and sensitivity, you will get the good data. If you have another instrument, your data may be a little bit more noisy. Another question as well is regarding the PSR 1100F. So the PSR 1100F is one of our instruments that covers the vegetation range. So it only goes to 1100 nanometers. But its resolution is high. It's 3 nanometer resolution in the UV-Vis. So that instrument is perfect for vegetation analysis. So if you are only looking at features below 1100 nanometer, then yes, you can definitely use this instrument with the pine needle. One question that just came on is it possible to calculate the percentage of water content of a leaf from the spectrum? So yes, it is. So spectral data will give you a qualitative approach to analysis. So what you get from your spectrometer is the spectral curve. Will show you the location of the absorption feature. However, the depth of those features is indicative of the quantity of that molecule that is absorbing that energy there. So if you look at the water absorption features, the deeper the features are, the more percentage of water there's going to be. So you can derive from your spectral data the percentage of water, but you would have to create a model of reference. So our software connects with chemometrics modeling software. So for instance, you can create a model in eigenvector. So you would have your reference samples of leaps at various percentage of water content. And then in real time, you can compare the spectral data to that model and get a prediction of the water content. Another question we have here is somebody wants more information about ground truthing of airborne data. Sure. So I mean, I can let Mac talk about this because he's our remote sensing specialist. So we'll let Mac answer this one. So let me give you the mic. So somebody wants to know more about ground truthing.
Excellent question. So the pine needle adapter, say you're trying to do a remote sensing study and you're ground truthing airborne or satellite data, you're going to have a coarser spatial resolution or spectral resolution, most likely. So what you can do is you can take measurements on a given coordinate or pixel, and you can take representative spectra from those, like conifers or any pine needle tree. So you can actually take measurements of that tree and then compare it to the pixel side or the pixels data. So that's how you would ground truth. So you can, for a fact the spectral reflectance measurements on the ground, and you can compare that reflectance measurement to the satellite's measurement for that area. And you can use that to correct it, or you can use it to classify different species. So you could theoretically plan a field event and take a bunch of reflectance measurements from known species of plants there, and then use it as classification data in your remote sensing project. So you could take essentially a small field day and then extrapolate it out to a much bigger area, which is one of the many benefits of remote sensing research. So there's many ways that you can integrate this data into remote sensing projects.
All right, thank you, Mac. There's another question that came in about the classification that Mag was just talking about. So, so is there a way from the spectral data to do classification and identification? So yes, you can do that. So with the naked eye, vegetation spectra kind of, they all look similar, but they have, some subtle variations in the absorption features that our software is able to detect. So we actually have a module in our software called EasyID, which allows you to do a comparison from an unknown spectrum to a reference library. So by doing that, you can actually do classification and identification of not only vegetations, but minerals, materials, etc. So the software will use some algorithm to look at the location of the absorption features, the depth of those absorption features, and derive the closest match in the spectral library of reference. And that gives you as well the option to build your own spectral library of reference. So, going back to the water content questions we had before, what you could do is you could look at the senescence of a leaf over time, and it's, the amount of water drying over time. You could take spectral measurements on that leaf over time, and then if you know what the water content is, you can use that as a reference for future measurements. So then it will compare it to your reference, and you can derive then an approximation of your percentage of water. So it's another approach to, if you want to do water content, but if you don't want a very complex chemometrics model to do that, you could do a simple comparison to known spectral data of reference. All right. So I think that's all the questions we had. So, if you have any more questions, you are always welcome to contact us. So you can send us an email at info, at spectralevolution.com. This webinar will be made available online as well. So you will be receiving an email in the next few days with a link to the webinar recording. Of course, Spectral Evolution is located in the US, but we have distributors all over the world that are able to support you in your country. So I see a lot of people here today from other countries. So we can put you in contact as well with our distributors that will be able to assist you. So thank you so much for joining us today. And we will be announcing the next webinar shortly. So we hope to see you there. Bye-bye.